In this video, we are going to talk about how to use z-scores to find the percentage of data between two values. So let's look at this example. In 1999, the scores of men on the math part of the SAT followed a normal distribution, meaning a bell curve like this, with a mean of 531 and a standard deviation of 115. What percentage of men scored between 430 and 630? So let's put some information on our graphs. And look, I recommend that you organize your work this way. You'll have to draw these little bell curves yourself. I believe you can do it. This line down the middle represents the mean. So I'm going to put my 531 right here. The reason why I have two of these is because on this side, I'm going to do SAT scores, or whatever the problem happens to be about. But on this side, I'm going to put the z-score version of this. So z-scores. Now, on a z-score curve, the mean is always 0. The mean z-score is always 0. Okay, now what? So we're supposed to find the percentage of men who scored between 430 and 630. Now those are obviously SAT scores that we're talking about, so I'm going to put them on the SAT graph. 430 is less than 531, so I'm going to put it over here on the left. And then 630 is bigger, so I'm going to put that over here on the right. And we're supposed to find the percentage of men who scored between these two numbers. So that would be this area of the graph that I'm coloring in yellow right now. Now, we have a chart that will help us find the percentages when we're dealing with z-scores. Let me show it to you. This chart gives the percentage of the data that's to the left of any z-score. And that's all we really need to know to answer these types of questions. Now, so here's the thing. We've got this chart that will give us percentages of the data relating to z-scores. But here we don't have z-scores, we have SAT scores. So the first thing we have to do is convert these SAT scores into z-scores, and then we will put them on our z-score graph. So we need to find what these two numbers are in z-scores. Now, here's the formula for z-score. I'm going to temporarily put it over here, even though this is not what this space is for. The z-score formula goes, the z-score is going to be your original value minus the mean divided by the standard deviation. So we're going to have to do that twice for this problem. So our first z-score, which I'll call z-score number 1, is going to be our first value, 430, minus the mean, divided by the standard deviation, 115. Okay, so let's see. Just put that in your calculator. All right, I'm getting a number that looks like this. I only want 2 decimal places, so I really want to cut this off here. It's very important that you round properly. Because this number is 5 or higher, then this number needs to be rounded up. So I'm going to wind up with negative 0.88. So there you are. And similarly, if we do the same thing with the second z-score, then you'll have this, all right, 630 minus the mean standard deviation, and you get 0.86 when you round that. So these z-scores go on the graph here and here. So somehow we need to find the percentage of z-scores between these two values. And we're going to use our z-score table for that. Now keep in mind that the z-score table gives you the percentage of data to the left of each z-score. And eventually we can use that information to find the percent of data between the two scores. But first we're going to do to the left. So what were those z-scores again? All right, so let's do one z-score at a time. So let's see, I want to create a little bit more room for myself here. Okay, so first I'm going to find the percentage of z-scores to the left of negative 0.88. All right, that's what this is. The percentage of z-scores less than negative 0.88. I can read that right off of my z-score table. Okay, I need negative 0. So this is 0, and this is negative 0. So here I have negative 0.1, 2, 3, 4. I need negative 0.8, which is here. But not only that, but I need negative 0.88. So glancing at the very top here, this first column would be negative 0.80. And then this would be negative 0.81, and then 0.82, 0.83, and so on, all the way down to this column. The second to the last column would be 0.88. So just remember that, second to last column. So this row is all about negative 0.8, but this is negative 0.8, 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the percentage of z-scores to the left of this value. As a percent, this is 18.94. So I'm going to write down 18.94%. Now let's do the same thing with the other z-score. The percentage of z-scores to the left of 0.86. Let's see, 0.86. So it's positive. So here's positive 0, positive 0.8. It's right here. And this is 0, 1, 2, 3, 4, 5, 6. All right, well, you can see it here as well. So this is the percentage of data to the left of that z-score. That's 80.51%. So 80.51%. Now, I want to know the percentage of data between these two numbers, not to the left. Well, first of all, here's the notation for between. I would say negative 0.88 is less than z, which is less than 0.86. That means the percentage of z-scores between these two numbers. Now, if I want to find that, all I have to do is subtract. All right, if I take the two left percentages and subtract them, then that will tell me the percent between. So I'm just going to do the bigger one minus the smaller one. Okay, and we'll see what we get. So I am getting 61.57%. Okay, 61.57%. So that means the percentage of z-scores between these two z-scores is 61.57%. That means the percent of SAT scores for the men on the math part in 1999 is the same percent. These percentages are the same. So this is also 61.57%. And that is really the answer to the question that was asked. Now, before we call it a day, anytime you're doing a real world problem, you shouldn't just give a single numerical answer. Instead, what you should do is write a sentence that includes the context. It's got to mention what the problem was about. So your final answer might sound something like this. 61.57% of the men who took the SAT in 1999 scored between 430 and 630 on the math part. And that is how you find the percentage of data between two values. You convert them to z-scores, find the left percentages off the table, and then subtract them. I hope this video was helpful. I'll see you on the next video.